Well, thank you, Les Robertson, for coming here today to speak with us. I'm going to ask you 7 questions on tall building innovation. So the first is, what was the most complex project you've ever worked on, and what are some of the biggest difficulties that you've had throughout your career?
That's 2 questions.
Well, they're both in tall building innovation.
Okay, but complex, I mean, there are 2 sides to that question. One is complex at the time, but perhaps very simple now. Mm-hmm. And the other could be complex now, and who knows what it'll be in the future, probably simple. Mm-hmm. So if we talk about the past, I could say really complex building, which is very simple today, would be the World Trade Center, because it was a kind of building that had never been built before, and those of us who are cautious, and we should be cautious, mm-hmm. have learned to read about the past and to then project into the future, not taking big steps, but taking sensible ones. But there we had to develop the whole science of wind engineering with completely different materials used, mm-hmm. and we developed a partition system that was very strong and much better than the partitions used in the past, but had a profound impact on the structural system. We developed a damper to ameliorate the swaying motion of the tall building and so forth. So, and the computer was rather different, right? I mean, we had the largest medium scale computer that, solid state, by the way, that IBM made, which is less powerful than your laptop today, but it was a room size machine. We called it the Cadet, which meant can't add, didn't even try. It added 4 to 7 to get 11 in a lookup table and so forth. So in programming, which because there were no structural programs, we had to make all of our own finite element programs and so forth, all done using what we would consider today be antiquated equipment. So it was very complicated then. Today, piece of cake. We could do it. So whereas complexity today is usually organized about things that you wouldn't think of as structure, that has to do with zoning and politics and so forth that make structures difficult. But not anywhere near the challenge of the Trade Center at that time. Mm-hmm. Today we could do the Trade Center in our sleep, but at that time it was a different story.
Great. Are there different considerations that you need to take into account when you're designing tall buildings in Southeast Asia compared to the U.S.?
First of all, you do probably understand that we do most of our buildings are not tall buildings. Mm-hmm. So, we have done in Asia, we've done quite modest buildings, done a few museums and so forth. But in terms of tall buildings, today, life is very different, because a tall building today, if you ask me what it is, I'd say, well, it's at least 500 meters high, because we're doing a host of them that are taller than that. And the differences have to do with the people that you're dealing with. I mean, culturally, the folks in Korea, for example, are quite different from the people in China, who are quite different from the people in Japan. So we're by necessity learning a lot about the culture and the history of the place before we set out to design anything. Right. I mean, you have to understand the people who are going to use this facility. So that would not be the case if we were designing in the United States, because we were born and raised here. So we don't have that issue. I don't mean to say that designing a Black Baptist church is the same as designing a Westchester County church of some kind, which is all very Caucasian. So there are still cultural differences you have to learn about, but it's very, very much simpler, very much simpler. The construction technologies are very different that are used in most of Asia as opposed to those used in the United States. That's particularly true in the foundation and basement construction and so forth are quite different technologies, and I have no idea why. That is, if we try to use a technology that we would use in Hong Kong and try to use that in San Francisco, we would get no place, because they don't want to do it that way. You want to do it the way they did it yesterday, which is a very reasonable thing to do. I'm not faulting it. I'm just saying so the two are quite different. In the Far East, we do what's called top-down construction. That is, we put in the basement wall completely in the ground, and then we build the floor at ground level, and then we dig underneath it and put the next level in below that, and the next level below that, and so forth. Whereas in the United States, we would perhaps construct the basement wall on the ground, perhaps not, but in any event, we would build it bottom up. And I happen to think that top down is better, it's safer, and in my view more economical, but it's not what people do, so you don't do it that way. The formwork that's used for a tall concrete work in Korea is incredibly complex piece of equipment, whereas if it were in New York, it would be carpentry work. Very simple, in other words. Does that make it better in Asia than the United States? I think that's a question of economics, and so it certainly doesn't make it faster. Okay?
All right. Well, you must have had so much experience designing things outside the U.S. So how has your most recent designs, such as the Shanghai World Financial Center, addressed the current trend towards sustainability?
I would say, first of all, most people would have difficulty defining the term sustainability. I think you'll find that's the case. Look, if we use reinforced concrete technology, which is commonly used throughout the world, it's used right here at Princeton, and it's used in Vietnam, wherever, to make a pound of cement, Portland cement, takes a very significant amount of energy, and for every pound of cement you get 1 pound of CO2. Right? Is that sustainable? Don't know. It's a complicated question, isn't it? We used to specify in our concrete a minimum cement content. Contractor had to use at least that much cement, and now we specify a maximum cement content and force the contractor to use non-Portland cement materials for making the concrete. And that would be true in Asia or in the Americas. Same situation. Structural steel is almost completely recyclable. As if you tear down the building, let's say 150 years from now or 200 years from now, you tear down the building, it all goes in to make new steel. It's just a completely recyclable product, whereas concrete is not. I mean, there are some uses for broken up concrete, but they're not very many. They're not very many. So, I mean, those say, well, why do you use concrete for buildings? Well, for one thing, it's a very economical product. It provides a lot of structural properties that are very desirable. And the really big issues in terms of energy conservation and so forth are being used all over the world for good economic reasons. That, for example, we do a lot of buildings where the air distribution is in the floor rather than in the ceiling. And the reason for that is the floor is just a huge plenum. There are no baffles in it, no ductwork, no nothing. Right. And you can put an air outlet anywhere on the floor you want. So each person can have his own temperature control. And better, filter systems are much better, the air quality is much higher, and research shows that you get maybe 3%, 4%, maybe even 5% more productivity out of people. That pays for that work just like that, no problem. So there's a kind of a battle going on between the cost and the benefit, and the person putting up the money generally sees benefit as, for me, it's not often that they say benefit for the forthcoming generations. It's hard to convince a lot of developers to think that way. Mm-hmm. On the other side of the coin, it's good public relations. And our role in the whole process is to use less material. Whatever the material is, wood, steel, concrete, doesn't matter. Use less of it. That's sustainable. And the other thing is to make a better place to live or work. Yes. So often we have a profound impact into the character of the building because we're able to think of better ways to use structure to make to make a better office or to make a better apartment or whatever, right? Mm-hmm. Or a better museum, whatever the structure turns out to be. But it's, if you want to make a scorecard, you'd say, well, you use less material than somebody else, therefore you're making more sustainable buildings than someone else. And the other person would say, well, but about these other arguments, steel, concrete, and so forth, that could argue in the other direction. Mm-hmm. And by the way, it is almost never, or maybe I should say it is never, that any one design discipline is the one that drives the sustainability issue, because mechanical work has a profound impact, the architectural work has a profound, structural work, plumbing has a strong, profound impact, and so forth. So it's a collaborative effort that puts together the great buildings.
Well, it's great to hear that all these things can come together and create better productivity for everybody.
That's the hope, yes.
Yes.
Well, it's not just productivity. I mean, if you have your choice to be in an apartment house, for example, that has smelly air or one that has beautifully clean air, which are you going to take, right? The clean air means you're going to be healthier, and on, right? So it's not a simple question, but on the other side of the coin, the goals are, I think, easy to see. Mm-hmm. They're easy to see, and we're all, as you are, cognizant of the need to produce buildings that use less energy, produce less greenhouse gases, and so forth. All of the issues that go with sustainability. Yeah. But with respect to structure, you have to remember that a lot of structures for buildings remain when the building is demolished, and then a new building is built around the existing structure. Right. So, and that goes back to many years. Look at the old Roman buildings that are still, some of them still being used. Yes. So that's pretty sustainable.
All right. Our next question is: when it comes to creating new forms and designs, does inspiration come from trying to solve problems in specific projects, or from doing outside research and eventually applying ideas as the opportunity to test them arises?
Okay. First of all, where do ideas come from? I think that's the heart of what we're talking about. Where do ideas come from? And I think you could say maybe they're out in the cosmos and you reach up and pick one and bring it down. Or putting it maybe in more believable terms, I would say to you that there really is nothing that's really new in building construction. Different forms, slightly different materials, so there's lots of little things, but something that's really, really, really new, it's pretty hard to come by. Mm-hmm. So if there was an idea out there that was done by your great-grandfather, and somewhere back in my mind, it's there, and in a maybe completely new application, I'm able to bring it out and use it. It's still not a new idea, mm-hmm. right? I wouldn't claim it's a new idea. It's just different, right? A little different from some other idea that you might use. So the process is really complicated. I think it has to do with the interaction between people. That is, if the three of us were working together, we would learn to talk about things, and each of us would have our own perspective, and out of that would come maybe a different way to think about a particular issue or problem or aesthetic or whatever. And it is, I think, that collaborative nature that makes it work. Mm-hmm. And I mean, over and over again, I read where Les Robertson developed this or this something else, and I say to myself, well, I'm not so sure about that. You know, I don't know, was it me or was it the person on the other side of the table or the one on this side of the table, or maybe all of us did it, all of us put it together. And to claim that it's your ideas may be a little stretch. I think that is a stretch. But there's another facet to it, and that is that young people have to learn to see things. It's very easy to go someplace and but when we walk out of this room and I say to you, well, how is the ceiling made? Would you be able to answer? Maybe not. You'd be surprised how many don't. In my classes at Princeton, I would say to the student, well, what's the color of the floor outside the classroom? And very few are able to actually come up with that. And the reason is that they have vision, but they don't see, understand the difference between the two.
Looking and seeing are two different things.
Two different things, right. So you have to, it's not something that comes to you. It's not God-given. It's something that you have to learn to do. You have to learn to see things. So it's like ideas. You say, well, you get ideas about structure. Well, how do you get ideas about structure? Well, there are a whole lot of things, and you should be looking at all these things and saying, could I do that better? How would I do that? Mm-hmm. In other words, got to say practicing. It's like practice. That's the way you get better at basketball or volleyball or whatever. It's the same with ideas. Mm-hmm. You practice, then you get better at it. That's not surprising, is it? Nope. But most people do not consciously do that. And I think you have to learn to consciously do that. Mm-hmm. Okay.
So, as someone who has been involved in the design of tall buildings for the past 50 years, what has been the most important innovation in the industry?
The most important I mean, the easy answer would be the computer, right? That's an easy answer because it has such a profound impact on our work.
I'm sure it is.
But if you look at the work of your grandfather or great-great-grandfather, for that matter, some pretty wonderful stuff was done, and there was no such thing as a computer. Mm-hmm. So what's happened is the computer has changed the complexity of the things that we can do readily. The then called the Pan Am building in New York City, the drive-through building on Park Avenue, now I think it's called the Helmsley building. Before Before Pan Am, it was the New York General building. No, it was always the Pan Am building. Sorry about that. That structural design was done on 42 drawings. Wow. I can do an outhouse in 42 drawings. I mean, the complexity of the project has changed so much that the computer is allowing us, encouraging us, demanding that we indulge in this complexity. And the good things and bad things. Out of it comes more sustainable architecture and engineering. That's good, right? Out of it comes a lot of cost often that maybe could be reduced significantly with simplicity. Mm-hmm. And so, but the computer has had a profound impact. The materials that are used in structures, let's say in 1900, and the materials that are used in 2000 are essentially the same. Same kind of trees grow the wood. It's no different than it was then. Well, it's certainly no better than it was then. At the turn of the century, most of the structures were iron. Now they're steel. Mm-hmm. But that was an evolution. It was not a step. It was slowly creeping along, and the introduction of steel into the technology. And reinforced concrete, the reinforcing steel is better, the concrete is better, stronger, stiffer, but not really revolutionary. Not really revolutionary. It's still the same old stuff, just improved, and will be improved as we go on in the next 50 years. All those materials are going to get better. We have now carbon fibers that, of course, products that are very much stronger than either steel or concrete. We don't use them in construction because, we do not use them in the construction of buildings because of the fire safety issues. And fire is the great destroyer of the things in buildings. They're the great danger. Whether it's 1 story or 150 stories, fire is a real danger in buildings. And all of us, the building services engineer, the architect, the structural engineer, all of us have to learn to work together to make the buildings more fire safe. And in that process comes the partition system that I said earlier we developed for the World Trade Center. Has made a huge impact on the improvement in fire safety, and by the way, also in energy consumption in buildings. So we each of us participate in the process. Often there's a fire safety engineer who maybe waves the baton, but the real thinking and progress that goes into it is a shared responsibility with everyone who's involved in the building, because it is the danger of all buildings, regardless of size.
So our last question on tall building innovation is, what drives the height of the tallest buildings?
So then you could say, well, why is it that buildings that are 500 meters and taller are being built, for the most part, in the Far East and not in New York or Chicago or Los Angeles or some such place? And there are a variety of answers to that. A part of it is that the cost of a major building is in part related to the building and in part related to the infrastructure to support it. So if you're going to build a big building, along with it has to come the transportation system, the electrical distribution systems, natural gas. You want to go on. The whole thing has to go together to produce a workable place to live and work. And in the Far East, the sort of government is seemingly much more interested in paying for that, whereas in much of the United States, the government would be looking at the developer to come up with with what it takes to make it work. So you cannot build a major building in Princeton because no way to get people here for that building. You can't even build it in many parts of New York City because the transportation systems are nowhere near sound enough to make it work. You cannot bring people by bus. You've got to provide rapid transit, and preferably underground or above ground. I'm an underground person, but in order to make it work. So it's a combination, I think, of infrastructure and government that drives big construction in localized areas. Now, why tall? Well, New York City, for example, has a very low energy consumption per capita. Okay, why? Well, there's several reasons. One, it doesn't have all that many roofs, right? It has lots of floors, but not so many roofs. And the other is that people don't drive. You walk or you take rapid transit. People don't. I have a car in the city, but I never drive it in the city. Never. I have never driven it in the city except to get there and leave. It's not in-city transportation, right?
Yeah.
So that makes it possible for me to live one place and work in another. Great transportation hub where my offices are, which are down at the foot of Manhattan, where almost all the subway lines go. So it's a great place to work. I'm personally not very fond of living there and don't. because I live just west of Lincoln Center, and this big cultural hub, which is so important to my life and should be to yours, by the way. I don't know if I've answered your question, but anyway, there is ego's got to be a part of it. So if you build one building, then someone in that same country wants to build one a little taller. So the height record lasts for a very short length of time. And it becomes kind of silly because people are putting these spires on top of the building and funny things that make no sense whatsoever. So it was interesting when we did the Shanghai World Financial Center, which has I guess maybe the tallest occupied floor in the world. I believe that's right. But it has no ears on the top. And so it's, depending upon how you count height, it's not the tallest building in the world. And in any event, we're working on several others that are taller, so that whatever record it had will fall shortly, and should. I mean, but the technology is improving. Things like elevators. There's now cableless elevators coming on the market. That makes a huge difference because the weight of the cables is an enormous impact on the cost of the elevator itself, because the elevator machine has to carry the weight of all this cable, and trust me, the cable weighs a lot more than the car. A lot more than the car. So the getting away from cables will improve the economy and the speed and the reliability of elevators. So, and right now we're kind of at the height limit. Can't go any higher pretty much than you can go. So almost all tall buildings are built with shuttle elevators, which were introduced first for the World Trade Center. In that case, the building was divided into thirds, so you could take an elevator to the third point, or you could take an elevator to the 2/3 point, or you could take an elevator to the roof, and they went nonstop. Right. So that improved the kind of cycle time, the time for people to get through the building. And while it's still not used much in the United States, in the Far East, elevators are used for fire evacuation, and should be, of course. So that's moving ahead in the United States, and we'll have that kind of thinking. So elevators going higher and higher and higher means you got to get rid of cables. So that's I think currently the height at around 500-600 meters is a practical height to buildings. Even the very tall building in the Emirates does not exceed that in terms of where people go. So when that improves, when elevators get to be better and more economical, then buildings will go higher yet, because the structure cost is not much, and the cost of having an office here and one over there, where you go down, go across, back up to this other place, that's very time consuming and it's inefficient. And no matter what you say, the electronic communication systems are not the same as the face-to-face communication. I mean, that makes a huge difference to the way you can convey your ideas. Some people are very good at the electronic things, obviously because we have television, right? Mm-hmm. But a lot of people are not. A lot of people are not, and it lacks kind of personal touch. I think that renders it useful, but not people really people friendly. Mm-hmm. So the tall building, which allows for really quick interface between this place and that place, is enormously valuable in terms of the economy of the place. I raised our daughter. What a terrible thing to say. We raised our daughter a block from Central Park, and we were in a 40-story building, and she grew up and went off to the university all her life. She lived in a high-rise building, and to say that everyone can live a block from Central Park is ridiculous, because you cannot. But still, I mean, it does not lack the kind of human properties. She had many friends in the building, And even when she was very small, she could circulate in the building where we wouldn't let her go out in the street, and so forth. So, and when she got older, in high school, for example, students from her high school would come to our apartment in the afternoons, and she's a kind of a baton waver, so she would get everyone to study instead of play. Hard on the refrigerator, but very good for the students. And that's because we were very central, right? You could do that. So the ability to get people close together is maybe the principal benefit of the high-rise building.
I see.
Okay.
Well, thank you, Les. That ends our section on tall building innovation. Our next section is on the World Trade Center, and we have Jasmine asking questions.
All right.
Hi, Liz. So the first question on the World Trade Center, what has been the effect of September 11 on the design of tall buildings?
September 11 was a kind of disaster in many ways, and yet we learned from disasters, and things have been learned. One of them, I think, that has been learned is that it is not appropriate or sensible, I would say, to design buildings in general to resist the impact of terrorist-driven aircraft. The World Trade Center was designed for the low-flying, slow-flying Boeing 707, the largest aircraft of its time, in a scenario not unlike the Mitchell bomber that struck the Empire State Building in the Second World War, lost in the fog, bang, killed 7 people. And the structure withstood the impact of the aircraft, ultimately brought down by the fires, but the structure brought it down because of the kind of robustness and redundancy built into the structural design. And that was not an innovation of the building. I think that earlier in the UK there was an event called Ronan Point. There was an apartment building. There was an oven explosion, a gas explosion that brought down the whole corner of the building. And so that was interesting, but it was a little building in the UK. But now we have something else where owner-developers could see that by providing a more redundant and robust structure, they could get additional safety. And so now, while the codes are not really very different, although there's some changes there also, the attitude of particularly the knowledgeable builders changed a lot, and they're prepared to pay for a little extra money to provide that level of safety. To say that buildings are designed for the impact of the terrorist-driven Airbus, the new one, I'd say I don't think so. I don't know anyone even contemplating that. Other things, we were instrumental in convincing the architect, Noor Yamasaki, and then Port Authority of New Jersey, the owner builders, that parking and truck docks and things like that should not be inside of the towers. They should be outside. And that's kind of complicated. It has to do with the fact that small fires can generate a lot of smoke, and tall buildings are like chimneys. In cold days, the smoke can rise, and as it did on the bombing of the World Trade Center. And so, but now it's very easy to convince owner-developers that they should not allow parking in their building. As a matter of fact, it's kind of axiomatic. You know, they would like to have cars maybe 30 feet away from their tall building. Not away from all buildings, but away from the, if you will, the really sensitive center of the building. So that's a change in the way people think about things. More effort being put in to produce fire-resistant elevators. They're not fireproof. Really, nothing is fireproof, but fire-resistant so that it's easier to convince fire marshals that You can use elevators to evacuate a building. Now, I would say to you that elevators would have been pretty useless, much of it, in the case of the World Trade Center, because most of that was destroyed by the aircraft impact. In the Far East, buildings are built with we call a refuge floor, that is, or floors. Let's say maybe as little as 12, as much as 24 floors apart. There are floors where there's nothing in the space that can burn. There's nothing in the space that can explode. And stairs come down or up to that refuge floor, and they exit onto the floor. And if you want to continue down, you get in another stair and continue down. Now, that's illegal in the United States. Stairs go from top to bottom and exit at ground. Is that a good idea? I happen to think it's an excellent idea. But in the case of the World Trade Center, if people had gone to refuge floors, then tens of thousands more would have perished because the buildings collapsed. But for the more ordinary circumstance of fire, it's an excellent idea. It provides a technique for getting people to a fire-safe place. And in the Far East, the elevators are used for evacuation of people, whereas in most buildings in the United States, that's not done. It would be illegal to do that. Philosophically, big changes there, and all that's being thought through and studied, and decisions are being made, and they're complex, technical, functional, and economic issues that go into that decision-making process. Should stairs be wider, or should we have more stairs? That's a good question. The very, very tall buildings we're doing today generally have 2 staircases. The World Trade Center had 3. Was the World Trade Center better? I don't know. But because people got down all right, but the problem with the World Trade Center is firemen were going up the stairs. But in the Far East, we have what are called fireman's lift. They're basically service lifts. And the firemen go up in an elevator. They do not walk up, which means the stairs are clear for going down. So maybe the 2 stairs are better there than the 3 stairs in the United States. You see, the interaction between custom and reality is pretty complicated sometimes. And so, anyway, I think that the events of September 11 have had a profound impact, but not so much in structural engineering. Not so much in structural engineering.
Okay, thank you. You mention in one of your writings that media spread many inaccuracies regarding the collapse of the original World Trade Center towers. So what do you think is the single biggest misconception that the public has?
You know, I'm probably wrong, but the architect Ian Pegg got the gold medal from the Royal Institute of British Architects, and so my wife and I went to London for the occasion. And very prestigious occasions you can imagine. Some people in tails, black tie, wonderful evening, very pompous and great. And the 4 of us walked out at the end of the ceremonies to the street, and 3 young people came up to us and handed out leaflets. And the leaflets were about the alternative theories of the collapse of the World Trade Center. Now we're in London, please understand. This is not New York or something. If I lecture in a school, particularly in the United States, I'm talking about children now, or do I dare call teenagers children? Probably I should not. Young adults and children. That's the thing that I'm asked about the most, by far. By far. There's a theory about the atomic bombs that were put there many years ago, and on and on. more theories than you can imagine, and a lot of bad physics and a lot of bad engineering has been quoted and quoted very convincingly to the public. The buildings collapsed faster than gravity would allow, and on. All these miraculous things, and by the way, some professors have been on that end of the teeter-totter. So whether that's the biggest one, I don't know, but it's maybe the most influential thing. But beyond that, there are other issues. I think the public has a very poor understanding, and no reason why they should have a good understanding, by the way, of the mechanism that caused the failure, the good and the bad about the World Trade Center in terms of its collapse. There are a lot of great things about the project, and there are a lot of things that we would all do differently. And they're pretty complex issues, and the media has an obligation to attempt to explain to you and me what transpired, and so they do so in a way which can, if it were a technical discussion, would be unprofessional. It's a tough line to sort through where the media has an obligation to be reliable, and where has an obligation to get across the big idea, even if it's badly presented, even if it's improperly presented. So I'm not blaming the media, by the way. It's their obligation to do the best they can. And these are complex issues, and the media, individuals in the media become expert on a subject overnight. That is, the Princeton Journal, whatever it is, I have no idea what the Princeton newspaper is called, but it does not have an expert on, you name the subject, high-rise building, rocket failures. You want to go down the line of all the things that there are out there. They can't. So people in the media become experts overnight, and they do the best they can.
Yeah. Okay, so what was the public attitude towards tall buildings in the 60s and 70s? For example, to the World Trade Center towers?
Well, perhaps the most famous architectural critic in the world, and certainly the most famous in the United States, is Ada Louise Huxtable. She's not now really writing much professionally. Wonderful woman. And she wrote a glowing article about the World Trade Center and as it evolved. And later on, as the project came much closer to reality, she changed her view because she saw the buildings as architecture rather than as sculpture. Or at least I believe that's the case, I think. And it's the kind of human nature to oppose change. And the site of the World Trade Center was kind of electronics industry, 5-story walk-up buildings. And you could go there and you could buy old vacuum tubes, transistors, and lots of things they don't even make anymore. And it was a kind of a fun place to go and wander around, and it was all destroyed. And from the excavation of the World Trade Center, the land was moved even farther out into the river, and that has since been expanded to produce Battery Park City. And that was resisted as an issue. At that time, to say that life was good, it's better in many ways and worse in many ways than it is today. But I think people resisted the change that went with it, and it was government Well, Port Authority, New York, and New Jersey is quasi-government. It's, let's say, half New Jersey and half New York, and it went into the real estate business, right? And there was a lot of opposition to that thought. The city had been through an era of development that a lot of it not good at all, a lot of it very badly thought through, and so people were appropriately reluctant to see change. On the other side of the coin, the project was being built over a transportation hub, so that the Path Railroad system, which was completely rebuilt for purposes of the World Trade Center, because of course a lot more people were going to be using it than they did before. The subway, the West Side subways that passed through the site, all the stations were refurbished and made modestly better. You could have made a lot better, but they were made at least modestly better, and so forth. So I think people sort of kind of grew used to it. And there were some other things that took place. There's a building to the north, one that collapsed, as you probably know from fire, that blocked a view looking south down an avenue, and there was a lot of opposition to that, particularly for the people who lived on the avenue or walked on the avenue and so forth. So there were a lot of legitimate complaints, I would say, about the construction of the World Trade Center, and there were a lot of great benefits that came with it. But I suppose the largest complaint was it was government. Yeah, it was government, and a different kind of aesthetic, and it really was sculpture instead of architecture. If you looked at it as architecture, it was kind of meaningless. But you know, if you could look at the buildings as the sun went down and watch the shadow go over the building, I mean, it was a pretty wonderful feeling. And I mean, a lot of great things. The way it shone in the sunlight. The fact that after it was built, you could often, with the right perspective, you could see right through the building to the sun on the other side, and so forth. There are a lot of fringe benefits nobody even thought about when it was being designed. Yeah. That turned out to be pretty wonderful.
And I guess you must have some, emotional attachment to it as well.
Well, I put in 10 years of my life working on the World Trade Center, and when I say 10 years, I'm talking really about, for the most part, 7 days a week and long hours every day. It was a huge, huge challenge to me. I'd never designed a tall building, but even I think that gave me an advantage over other engineers because I wasn't biased with a lot of rubbish. So I was able to look at things more clearly than the New York engineers, because I was coming from the West Coast. But 10 years is a long time, and I have been unwilling to work on the kind of reconstruction of the project. I figured 10 years is enough for any site. So I devote my time to other sites rather than that one, and we have really good partners and other engineers who do that work. I don't do it myself. I didn't talk to the press following the event until the best part of a year. And mostly because I found it very difficult to do so. And I really didn't have anything to say that I thought was useful. And there were a lot of private matters. I had people come to me who lost husbands or wives or sisters or brothers or children who thought that I could provide knowledge that I wasn't able to provide. And so I was kind of constantly immersed in the emotional side of the problem. I mean, even today I probably get 500 letters a year on the matter of people. So, and by the way, almost exclusively pro, if you will. They're not blaming me for something. They're thanking me for something.
Okay. Yeah, thank you very much. We just have 2 more questions, which are on education. Being seniors and about to graduate, I guess we're very interested in what careers are out there and stuff. So anyway, the first question, what advice would you give to yourself if you were an undergraduate senior in civil engineering trying to get into the industry with ambitions towards designing tall buildings?
Well, the 2 facets of that, the tall building you threw in at the end, I didn't expect that. But well. Let's start with the first part, which is advice to a senior who's looking towards the future. And I would say that the field that I'm in, which is structural engineering, the learning curve is very steep and very satisfying. It's a wonderful profession, and very competitive. And the first thing I would say to you would be, well, you have to have a master's degree, so go back to school. Right. Now, there are economic issues there. A lot of students can't afford to go on to get a master's degree. Do you absolutely have to have one? I don't have one. And my first job was as a mathematician. So I don't think it's the only road, but it gives you a head start on the profession, because in the year or 2 that you use to get a master's degree, you spend much of that time studying just your discipline. So that's very important. And then there are 2 issues. If you smoke, quit. If you're going to be successful in life, you cannot walk into somebody's office smelling like cigarettes. You just cannot do it, because you're not going to get invited back in again. So whether it's pipes or cigars or cigarettes, it doesn't matter. Quit for your own benefit, health and other reasons. But if you want to get along, and then you have to. Besides, you can't smoke anyway. We haven't allowed smoking in our office for many, many, many years. And then there's another one which might surprise you a little, and that is that if you want to do well in my field, you have to be conversant in the arts. You have to know about literature and music and dance and theater, and be able to talk to people about it. You can't make up. There's no way to wing it, as the saying goes. If you haven't seen that play, you haven't seen it. It's as simple as that, right? So you have to know the culture of the place where you live, and you have to know it really well, because the people that you're dealing with, a lot of them are very interested in that. Mm-hmm. And it's this communication between you that makes for great projects. So learn about the arts, and I think Princeton, better than almost any university, does a good job at that. But even so, I think there's a lot of room out there, and I'm not saying they should be teaching you courses in art appreciation or how to paint or something like that. I'm not suggesting that. I'm saying is that you as a person have to get out from behind your computer and get interested in the arts and science and politics too, by the way. I would say I don't mean being a politician, but I mean understanding politics, which is an important part of your life. My wife and I, we're activists. We rent buses and take people to Washington to protest. So we're maybe overboard in that end, but still, understanding of politics or being able to converse intelligently about politics is good for you and good for your relations with other people. Now, what other advice? I personally think that in all of the engineering disciplines, structural engineering is the best. It's the most satisfying. because you can take your family, your wife and your kids and husbands and aunts and nephews and so forth and say, hey, look, and put your hand on it. I did that. I mean, and it's a wonderfully satisfying experience. So I think structure would be to go into structures. We have probably professors in other forms of civil engineering, and they're going to murder me when I walk out of the studio, but that would be my advice, to go into structural engineering.
Okay, so final question. In an article, you were quoted saying that young engineers need to think about the building actually getting built. How did you learn about the concept of constructability, and how can young engineers learn this as well?
I think earlier I said something about opening your eyes. Construction is going all around you, and maybe it's 3 blocks out of your way, but you have to go there and look at it. There's another facet to it, that is that the concept that dolls are for girls and trucks are for boys, which is really stupid in my opinion. Trucks are for both, as the saying goes. And
what about dolls?
I don't know. I'm not opposed to dolls for boys. I'm just saying that that more for boys than for girls, in particularly in the past. Boys learned to make things, build things. Maybe they had whatever kind of toys there are around where you can assemble them into things and so forth. It teaches you how to think, maybe about, you have to do this before that and so forth. We did a museum in Japan where I think there were like 5,000 pieces. Each one had to be interrogated to make sure it could be put in place so that the next piece could be put in place, the next piece, and so forth. So you have to, I guess you have to recognize you have to do that. How you do that, I think that's experience. I don't know that there's a place for the university in that act. I think maybe the building things as children is important. I think if you want to be a structural engineer, probably important, maybe not. I don't think I ever had any toys like that. But I was raised in the Great Depression when not much around in terms of toys. So, but I think that would be valuable to boys and girls alike. I think seeing things, you just taking the time to stop by and spend a half hour at a construction site, not just once a year, but regularly. Because construction is constantly going on. Even when construction is dead almost, there's still a lot of construction. You'd be amazed how much there is. And I'm not talking about big buildings. I mean, you can learn about a lot from looking at little buildings as well. And most engineering students are not interested in learning about wood construction, but in a sense it's a wonderful teaching material because it has all the bad properties of all materials. You know, it has different properties in all directions, and it cracks and shrinks and swells and, you know, all kinds of awful things in terms of making more precise the world of structural engineering. So I think working with wood is a good thing, by the way. I think, you know, it doesn't hurt to know how to saw, or I guess nobody has a saw anymore. They always use this tool, right? I don't know. Good question. I'm probably not qualified to answer.
No, I think there's some very good advice there.
Okay, I hope so. But go on and get your master's degree. That's the most important thing. Facing a graduating senior, by far the most important thing. And not necessarily whether you're going to school at Princeton or Caltech or MIT, it doesn't really matter. I think it's best to go on to a different university. That's my experience. And I happen to be moderately opposed to the go off and work for a year or two and then come back. I would rather that the student go right on through as a continuing process. And the two sides to that. One of them, I think, is that teaching courses to two different kinds of students. One who's just coming through from getting a bachelor's degree, and one who's been out working for a few years and comes back. Their needs are very different in terms of that which is taught. So my experience is that most of people who teach are really pretty much going down a road that they know well, and I'm not so sure that they're really all that good at these two kinds of people walking through the door at the same time, because they're very different. In my field, structures, by the time you're 30, you will know whether or not you're going to be a big success. You may not be a big success, but you'll know that you got it, as the saying goes. If you're studying the dance, maybe 16, 18, you know you're going to make it or not. And so, I mean, the big difference between professions, and it's not necessarily an intellectual thing. Architecture, I think, is older, maybe 40, and so forth. But in structural engineering, I think if you work hard, you will done, and you go with a good company, you've probably done most everything by the time you're 30 years old. You've done a concert hall, you've done a high-rise building, you've done maybe an outhouse. We do a lot of sculpture in our company, so maybe you've done some of that too, and on and on. So you get a breadth of experience and a breadth of looking at things. And you learn it very fast. Yeah.
Well, yeah, that concludes our interview. Thank you so much for coming.
Thank you very much.
No, it was my pleasure, actually. It was very nice to meet you both. Are you both going on to graduate school?
We're working on it.
Well, yeah. Anyway, I advise you to do that if it's at all possible. I know there are economic issues and others, but and the hard truth is that we don't hire engineers who don't have a master's degree. And in short order, it's said that we required for licensing a master's degree. I doubt that very much myself, because no matter what the professional societies say, they don't license anybody. It's just done by state, by state, by state, by state, and it'll be a while before that gets into the books. Is it better to do the master's degree or do without? I mean, I did without, somehow survived. It's a very, very personal thing, I think. But if you two came into a company like ours and started at the same time, you have a master's degree, you have a bachelor's degree, you have a huge advantage over what you can do and know and what has to be taught to you and so forth. You have a huge advantage. So it behooves you to be at the top of the competition, as the saying goes. Interesting enough, the difference between that and a PhD, I think, is smaller. We have both master's and PhD people in our company. I think the difference between the two is largely their intellectual capacity and less their education. And energy is very important. Well, we staff our office knowing that sometimes we're going to be very busy, we're going to be working up here, other times we're slower, we're going to be working down here. We staff the office at this level, so everyone works overtime. There's a lot of extra hours goes into the work, and if the job's going out and you're going out on a ski trip, the people who you're working with are going to expect you to cancel and stay.
Yeah.
Get that master's degree.
Yeah. And then a lot of hard work follows.
Yeah, nothing comes free in life, actually.